Hello AP Statistics students. In this video we are going to be looking at displaying bivariate quantitative data this time. In the previous video we were looking at categorical variables. Now we're moving on to quantitative variables, and that's where we're going to be spending the rest of this unit. So we're going to be using scatter plots. We're going to be describing those scatter plots, their association using these four features: form, direction, strength, and any unusual features that we may see. All right, so here I've got a great example of a scatter plot. This was a great activity that maybe someday we'll be able to do. Looking at hand span, that is the distance from your thumb to your pinky, how as far as you can stretch that out, and the number of starbursts students could grab out of a jar. Wouldn't that be a fun activity to do? But this scatter plot shows the association, the relationship between those two variables, where simply your x value is one variable and your y value is the other variable, and then you simply graph them x comma y, of course. Now we look at the scatter plot. It is important to be able to read them. So if I pick one point in particular, like this one, that is a person with a hand span of 21 centimeters, and they were able to grab approximately, maybe 23 or 24 starbursts out of the jar. Now a little bit more vocabulary for you. We've got special names for the y variable and the x variable. So the y variable we call the response variable. All right, this one up here is the response variable. Think outcome. You are trying to predict this one. Usually, that can get a little wishy-washy sometimes, but it's usually the one you're trying to predict. How are you predicting it? By using the explanatory variable, and that is the x. So again, think the word explain. We think hand span will explain how many starbursts you're able to grab, okay? Or we think the hand span will predict how many starbursts you will be able to grab. So we want to use that vocabulary a lot. Response variable is your y-axis, and explanatory is your x. All right, association. You're going to see this word around all the time. It is simply a relationship between two variables. If we have an association, we believe there is a relationship between two variables. And what we believe is knowing something about one variable will help us predict the other. All right, we think there's some sort of relationship. The association is the technical term for that. So, if we think there is a relationship, an association between two variables, how do we describe that relationship? Well, there are four things we want to talk about for an association: direction, form, strength, and any unusual features. These are the things we're looking at, what we're looking for when we look at a scatter plot. So first, direction. All right, simply, is your scatter plot going up or going down? A positive association means your scatter plot simply looks something like this. All right, as you increase one variable, so does the other variable also increase. Hopefully you see the rise over run there. It is a positive slope. All right, then we also have a negative association. And you can probably guess what that one is going to look like. So there, if one variable increases, all right, so again, if I go that direction on the x, the other variable, though, decreases. All right, it's not a negative and a negative because two negatives make a positive. This is if one of them is positive, the other one is negative. Okay, that's a negative association. So the direction is the first thing we want to describe. Next is the form. Okay, two things the form can be. It can be either linear, all right, straight. Remember, linear means straight, or nonlinear, also known as curved. All right, and that's as specific as you need to be. If it looks straight, call it linear. If it doesn't look straight, I don't care what kind of curve it is, it's just non-linear. All right. All right, strength. Why can't I slide up? There we go. Strength. So just now, if it is linear or curved, how strong is the pattern? And so here we're looking just on a continuum from strong all the way to weak. Okay, and in the middle you can have moderately strong, or something like fairly weak. It's sort of a continuum from strong to weak. How good is the linear line, or how good is the curve that you see? How close together are the dots? How strong is that pattern? And so there's some vocabulary you can use for strength. All right, unusual features. So if there are points that break the form, okay, points that break the form. Something that doesn't fit. Think some kind of outlier. Okay? And we'll see a few examples of that here in a bit. All right, so now just rapid fire, I want to take a look at some scatter plots here and sort of describe what you might call them. Okay, so this one, to me, looks fairly linear. All right. In terms of association, this is a positive association. Probably should have put that before the linear, but that's okay. A positive linear association, and that one's probably moderately strong. You'll get a feel for the strength just through practice. All right, those dots look like a pretty good straight line, so I might go moderately strong on that one. All right, next one over here, definitely not a straight line. The curve is generally going down, so this is a negative association. And those look like a pretty strong curve there. The dots all, I'll use the word line up, even though it's not a perfect straight line, but they all seem to be in a line together. So I would say that's a strong association as well. So a negative, strong, but it's not a straight line, so non-linear. Or you could say curved is just fine. All right, let's do these next two. So I look at this one. It looks kind of straight, so I think I will go a negative linear association. But as you can see, those points are fairly spread out. It doesn't make a very great line, so I would call that one weak. Okay, so negative linear weak. And here I do see one point that kind of looks astray. It doesn't look like it's where it's supposed to be. This one right here. So we have a bit of an outlier at, what is that, 2,000. Oh, the Y scale doesn't even go up that high. Definitely an outlier. So 40, 80, 120. That's probably at 160 maybe. Yeah, the Y scale doesn't even go up. Definitely an outlier. So yeah, an outlier does not have to be far to the right or far to the left. It can be above or below your general form. And the last one here, hopefully you don't see a line there or a curve there. This one has no association. It doesn't look like vacation days are going to help us predict or talk about food costs at all. It doesn't look to be a relationship, so I'd say no association. All right, that was kind of rapid fire there, just to get you an idea. Let's do something a bit more in depth. All right, so here's one from the book. We'll actually write good answers here with a complete sentence with context in it the way that we're supposed to. All right, so describe the relationship in each of the following contexts. So A, the first one on the left. The scatter plot on the left shows the relationship between the duration in minutes of an eruption and the interval of time until the next eruption in minutes of Old Faithful during a particular month. All right, so we are going to describe this association here and try to be fairly accurate and complete, thorough, using context, context, context. So I look at that, I see linear. It looks pretty strong to me. It's going up, so positive. So there is a strong, positive, linear relationship between the duration of an Old Faithful eruption and the interval between the eruptions. All right, so I put context in there. I described the strength, the direction, and the form. The only thing that I should still put in there is, do I see anything unusual? And I'm glad I did this one because I did forget one thing. Hopefully you can see we've got sort of two clusters here. All right, there is a cluster of points right here and a cluster of points right there. That is worthy of taking note. So I'm going to scroll back up here. Sorry. Unusual features, not only outliers, but also clusters of points. All right. That is also an unusual feature that you should take note of. So let's add that in here. There are two clusters of points, one at 2-minute durations, and what does that look like? So that's about 2 minutes. This cluster somewhere centered on 2. How high? Maybe 60 at a 60-minute interval. Come back, text. And 60-minute intervals. And the second cluster is around, I'd say that's a 4.5-minute duration with, I don't know, call that maybe a 90-minute interval. So again, we describe the strength, the form, the direction, and then any unusual features that we see. All Next one to the left, what do we got here? The scatter plot on the right shows the relationship between the average income, gross domestic product per person in dollars, and fertility rate, number of children per woman, in 187 countries. All right, so what do we have here? So there is so we want to go strong, moderately strong. The dots look pretty close together. I would say either strong or moderately strong on this one. I'll go moderately strong. Let's see, the dots though are going down and to the right. They're decreasing, so that is a negative. Definitely not a straight line. Non-linear relationship between the average income of a country and its fertility rate. Now look, are there any unusual things about this graph? And I'd say I do see one outlier right here. All right, not so much. I could see why you might be tempted by this one, but that kind of follows the form. If I think this curve right here is coming down this way, those, while they are way out here, they kind of follow the form. The one that really doesn't, this one is way outside the form. So, give me back my text, please. There is one outlier country that has an average income of, call that, I don't know, 35,000 maybe, and a fertility rate of, looks a little less than 5 on the Y, doesn't it? So let's call that like 4.8 children per woman is what that unit was up here. I got that from the country. The fertility rate was measured in number of children per woman. All right, so that's what you want to be able to do with a scatter plot, is to describe those 4 aspects. All right, the direction, the form, the strength, and unusual features.